Did you know? Right now, thousands of tiny earthquakes are happening around the world, but you can't feel them. Some places shake constantly, while others barely shake at all. Why does this happen? Let's explore with LEGO. The Earth's outer layer is made of giant puzzle pieces called tectonic plates. These enormous plates are always moving, but super slowly. You'll never notice it, but right under your feet, these Lego-sized pieces are shifting around all the time. Sometimes these giant plates push against each other and get stuck. The pressure builds and builds, like twisting a Lego brick tower harder and harder. Then snap! The plates suddenly slip past each other. That sudden movement creates vibrations we feel as earthquakes. Earth has 7 major tectonic plates and dozens of smaller ones. Each plate moves at different speeds. Some move just centimeters per year. When these plates meet, 3 things can happen. They collide, slide past each other, or pull apart. Each creates different earthquake patterns. Here's something fascinating. Places near plate boundaries have way more earthquakes than places far away. California, Japan, and New Zealand sit right on plate boundaries, so they shake constantly. But Kansas sits in the middle of a plate, so it barely shakes at all. Subduction zones are where one tectonic plate slides under another, like a Lego brick being pushed under another. These create the biggest, most powerful earthquakes on Earth. This is why places like Chile and Indonesia experience such massive, dangerous quakes. Here's something wild. Earthquakes don't happen randomly. The Earth is like a Lego tower being slowly twisted. The longer plates stay stuck without moving, the more stress builds up. When they finally snap, that's when you get a massive earthquake. This means something counterintuitive. A place that hasn't had an earthquake in decades might actually be getting ready for a big one. Scientists can tell there's stress building up, but they can't predict exactly when it will happen. It's like waiting for that overstuffed Lego brick to finally pop. When tectonic plates slide sideways past each other, like in California, they create moderate earthquakes that happen frequently. When plates collide head-on, like in the Himalayas, they create rare but incredibly powerful earthquakes. It's like different Lego brick collisions. Now imagine pulling apart 2 colored Lego plates very slowly. That's what happens when the Iceland plate and European plate pull away from each other. These spreading zones create smaller earthquakes, but they also create new crust and awesome lava flows. When earthquake waves shake buildings, it's like someone shaking a Lego tower back and forth really hard. Old buildings are rigid like tightly packed Lego bricks. They can't flex, so they crack and fall. Modern buildings are flexible and can sway like loosely stacked bricks. Engineers use special tricks to protect buildings in earthquake zones. Some buildings have shock absorbers on their foundations, like springs under a Lego structure. Others are designed to be super flexible so they can bend without breaking. Pretty clever, right? Let me give you a relatable example. Imagine your parent making spaghetti and putting a big pot of pasta on the stove. That boiling water is actually like Earth's hot mantle pushing on tectonic plates. Ready to see how this works? The boiling water bubbles building up in the pot represent stress slowly building at plate boundaries. It builds and builds, getting hotter and more pressurized. Just like tectonic plates, the water is looking for a way to release that pressure. When those steam bubbles suddenly burst and escape, whoosh! That's exactly like an earthquake happening. All that built-up pressure is suddenly released in one dramatic moment. The water splashes everywhere, just like earthquake waves spread through the ground. And notice how the spaghetti jumps around in the pot when those bubbles escape? That's exactly what buildings do during an earthquake. The ground shakes, and everything on top of it shakes too. Your spaghetti is experiencing its own tiny earthquake. So here's the funny part. Next time your parents cook spaghetti and it goes everywhere, you can say, "Don't worry, that's just a tiny earthquake in our pot." Your parents will either laugh or give you a very strange look, probably both. Scientists measure earthquake strength using the Richter scale from 1 to 9. A magnitude 1 earthquake is so small you don't feel it. A magnitude 9 is absolutely devastating and can cause massive damage across entire countries. The biggest earthquakes in recorded history were magnitude 9 or higher. The 2004 Indian Ocean earthquake was so powerful it triggered tsunamis that traveled across entire oceans. That's the kind of power we're talking about with tectonic plates. But here's something amazing. Most earthquakes are tiny. In fact, thousands happen every single day that nobody notices. Only the big ones make the news. The Earth is constantly adjusting itself, releasing small amounts of pressure regularly. Scientists use special instruments called seismographs to detect earthquakes we can't feel. These machines draw a line on paper. When an earthquake happens, the line goes crazy with big wiggles. It's like the Earth is drawing with a really shaky hand. Earthquakes also happen under the ocean, creating underwater tectonic plate movements. These can cause tsunamis, massive waves that travel across ocean basins. A tsunami earthquake can affect coastlines thousands of miles away. Countries in high earthquake zones like Japan and Chile have special buildings designed to survive big quakes. Some buildings actually sit on giant spheres or springs that absorb the earthquake energy. They're like buildings on bouncy Lego springs. Scientists can't predict exactly when earthquakes will happen, but they can predict where they're likely. By studying plate movements and historical earthquake patterns, they identify high-risk zones. This helps people prepare and build stronger structures. Early warning systems can detect earthquakes and send alerts before the shaking reaches you. Seismic waves travel slower than radio signals, so scientists can warn people a few seconds to a minute before impact. Those few seconds matter. There's also something called earthquake aftershocks, smaller quakes that happen after the main earthquake. These occur because the ground is still adjusting and releasing remaining stress. It's like when Lego bricks finally settle after being shaken. Some animals seem to sense earthquakes before they happen. Dogs, birds, and other creatures often act strange just before quakes. Scientists think they might feel tiny vibrations or sense pressure changes in the air that humans can't detect. Learning about earthquakes helps you understand that Earth is alive and constantly changing. The ground beneath your feet is never still. It's always dancing to its own rhythm. The planet is dynamic, powerful, and absolutely fascinating. So now you know why the Earth shakes. You understand tectonic plates, stress buildup, and earthquake behavior. You're basically an earthquake expert now. Go impress your friends and family with your amazing seismic knowledge. Remember, earthquakes aren't random disasters. They're Earth's way of managing stress and reshaping itself. Every shake, every tremor is part of our planet's incredible story. Pretty cool, right? Now go out and share what you've learned.